You're welcome to Science Spectrum with Don. This is the third part of the third lecture in measurements of physical quantities. Alright, now from the previous class, we talked about the errors in sum. In other words, if you're given measured values with their errors, how do you report the sum of those measured values? Of course, that implies if they're of the same units, right? You are specifying the same physical quantities. Alright, so let's say for example, for instance, alright, now I need to reproduce errors in sum up here. So this is x is the sum of two measured values, and if I'm to give the sum, right, of the measured values, this would be x plus or minus the absolute error in the first value plus the absolute error in the second value. Alright, now I need to box this for reference purpose. Alright, so it's a quick one now. So let's say for example, the volumes of two bodies were measured, and then the first volume of the body was measured. The first body was measured to be 10.2 with an error of 0.02 in cubic centimeter. And the second body measured to be 6.4 with an error of 0.01, all in cubic centimeter. Now the question is, find the sum of the volume, with its error limit, and of course its error limit is simply the absolute error. It is error limit. Alright, now I may need to come back to what absolute error is all about just in a moment. Alright, so this would be from the formula up there, is written up there. Alright, so the sum of the volume is simply, so x in this case now would be v1 plus v2, v1 plus v2, this is the solution. Alright, and this is v1 is 10.2, then v2 is 6.4, all in cubic centimeter. Alright, now 10.2, 6.4, this is 6. This is 16.6, so this is 16.6 cubic centimeter. That is the sum of the volume. Now that is what this is all about, x, v1 plus v2. Alright, but the absolute error is what you see here. So the absolute error now, so this is v1 plus v2, I could just call that a v, just like you have the x now. And of course the absolute error in the first volume is 0.02 plus the absolute error in the second measured volume is 0.01. And of course all is in cubic centimeters. So what it simply implies is the sum of the volume is 16.6 cubic centimeter, and of course I could stick in a plus or a minus now for the absolute error, which is this part. So this would translate to, of course I will just call this a v, and this would be 0.02 plus 0.01. This is a 3. So this is plus or minus 0.03, and of course I could just stick this in the bracket. I could stick in 16.6, and of course I could just stick in the units outside. Now, so I have reported the measured value of this volume with their errors as the sum of the volume, right? Then I stuck in a plus or a minus the sum of the absolute error. Now let's see in somewhat more detail what absolute error is all about. Alright, now we need to beam this for a while, and of course I could just clean this up. Alright, so we proceed to absolute error. Absolute error. So let's talk about absolute error. Now, absolute error is simply the difference, or simply error, the difference in your measured value, okay? Measured value minus the true value. That is absolute error. Alright, so let's take for instance, let's say you were given several measured values, they were repeated. So we have A1, we have A2, A3, A4. These are measured values, and of course this could go up to the last value. Now, if you would report a single value that would represent all of these measured repeated values, that single value is always the mean. It's always the mean value. And that mean value, we could see that as the true value, as the true or real value. Right? So what's simply the mean? The mean is simply the sum of all of these measured values, the sum up until the nth value divided by, okay, the number of values you have altogether, and of course this is the mean. So the mean is simply the sum of the measured values starting from the first value to the last value, and of course divided by the number of, okay, values you have there. Alright, so this is simply the mean when you have repeated measured values. The mean will tell you, or can be classified as the true value. Now we could also talk about the errors in the measurement. That error is what we just discussed a couple of minutes ago as the absolute error in the measurement. So what is simply absolute error? Absolute error, absolute error, absolute error, absolute error is just the change, right? It's simply the mean value, which is the true value, minus each of the measured values. So this is the symbol for absolute error. And of course, what is absolute error? It is simply the mean value minus each of the measured value. And of course, I'm taking the magnitude of that. What it implies is I could throw up the minus sign, right? All right, now, but since I have several of these measured values, right? It simply means I could take absolute error for the first, for the second also, right? For the second, I could take for the third, I could take for the third, and of course, I could take up until to the nth value, right? So it simply means I could also take the mean of the absolute error. So the mean absolute error now, the mean absolute error will now be that error, right, that I could report alongside the true value, right? So that would be the measured value with its error, since I have several of the repeated values. So the mean absolute error is simply the sum of the absolute error, this, right? Sum of the absolute error plus for the second, for the third, up until for the nth, right? For the nth value divided by number of values you have there. So this we really call the mean absolute error. Absolute error, sticking the mean down, and since it's a mean, I'm sticking a bar above it. All right, so let's do a few examples. Okay, so I could be more quantitative about this. All right, so the first example, let's take for instance that the diameters of, let's say, a lead ball was measured with a micrometer screw gauge, and it was given as, okay, it was repeated. So let's say the first diameter was 2.620 cubic, let's say centimeter, the diameter. The other one is 2.625 centimeter. The other diameter was repeated. Keep on repeating. So it was found to be 6.628 centimeter. The other one was measured, repeated, and it was found to be 2.630 centimeter. And of course, it was repeated again and found to be 2.626 centimeter. Now, how do I really report what the true value or actual value is? Of course, it is the mean of each of these measured value. And how do I really report the error? The error has to be the mean absolute error. All right, so a unique number will specify what the true value is, that's the mean. And a unique number will specify what the error in the measurement is, and that is the mean absolute error. All right, so we proceed now. The mean to start with, the mean error, the mean value is the sum of everything. That's 2.620 plus 2.625 plus 2.628 plus 2.630 plus 2.626. All is given in centimeter. That's the diameter of a ball that was measured with a micrometer screw gauge. All right, and of course I have to divide everything by 1, 2, 3, 4, 5. Okay, this was repeated 5 times. So the measured values are repeated 5 times, so this is divided by 5. Alright, just you can read out from this. So we proceed from here. Now if you look at the measured values, they are all given to 3 decimal places. So I could just factor out, now this is 1, 2, 3, that's 10 to the power minus 3, 10 to the power minus 3, so I could factor out per minus 3. So the mean value now will become 2620 plus 2625 plus 2628 plus 2630 plus 2626, right? In centimeter, right? But times what I factored out, the 10 raised to power minus 3, 10 raised to power minus 3 in centimeter, then divided by the number of values. My calculator, this is 2620 plus 2625 plus 2628 plus 2630 plus 2626. All right, and everything boils down to 13129. So this is 13129. So the mean value is 13129. Of course, I have times 10 to the power 3 and factored out, and this is in centimeter. And of course, I could divide this by 5. So if I divide by 5, divided by 5, the answer boils down to be 2625. This is 2625.8 times 10 raised to the power minus 3 centimeter. And of course, minus 3 means this will go 1, 2, 3 decimal places backwards. So I have 2.6258. And of course, I could have reported this to 1 6 feet, but since these measured values were given to 3 decimal places, I have to take that into account. This is 1, 2, 3, and after the 5, I have an 8. So we could round 8 up as 1, and this becomes 2.626 centimeter. All right. Now we'll talk about the absolute error in each of these measured values, and of course, I could take the mean, and that would determine what the error is. All right, thank you for tuning in. You want to like, share, and subscribe for more content. Thank you.